And this relates back to question number 1. Okay, so question number 1, we are trying to find the solution to the system of linear equations. So previously I described that another way to write it is that we want to find a point of intersection between these two lines. Now there could be three different answers, or there are three different types of solutions. Okay, we can either have no solutions, one solution, or infinite solutions. Okay, now if we were to have three linear equations, then we would possibly have multiple other solutions. Okay, but in a case where there's only two linear equations, we can either have no solutions, one solution, or infinite solutions. And I'll get into the cases of why. Okay, so if we had zero solutions, this means that the linear equations have no point of intersection, or POI. Okay? And this is mainly because they have the same slope and they're parallel to each other, or that's essentially why. They have the same slope, or they have the same positive slope or negative slope, and they never intersect each other. Okay, so that's why they have no point of intersection if they're parallel to each other. Okay, and if you want to visually represent it, it will look like something like this, where there's two lines and they're parallel to each other, so they never intersect. Okay, so they have the same slope, not the same y-intersection. So, if there's one solution, that means the linear equations have one point of intersection. Okay? That means if I were to graph it out, that means that they're not parallel to each other, they don't have the same slope, so they look something like this. It could be a positive, negative slope, it could be positive, positive, doesn't really matter, but there's one point of intersection here. Okay? Now, if there are infinite solutions, linear equations have infinite point of intersections. Okay? Right? Oh, this was supposed to be in green. Whoops. Okay. So what does it look like graphically, right? So if the linear equations have infinite solutions, that means that they are the same line, basically. So there's only one line, and that means that they intersect infinitely because of the same line. Okay? So when you're looking at a system of linear equations, you need to keep this in mind, right? Because it's very easy for us to just dive right into using the techniques of substitution and elimination. But if you're able to understand the concepts behind this, then you're able to just analyze a system of equations and come to a conclusion. Does my system have one solution, zero solutions, or infinite solutions? Okay? So let's look at our example here. So we have y equals 5 over 2 times x plus 2. And we also have 2y equals 5 over 2x plus 4. Okay? So you can take your pick on which one to use. I'm going to use substitution. Okay? So that means that I'm going to isolate for y for our second equation. So that means I'm going to divide both sides by 2. Also, this shouldn't be divided by 2. It should be 5x. Okay, so for 2, we're going to isolate for y, and we're going to divide both sides by 2. So we get 5 over 2x plus 2. So now, here is our system of linear equations. Let me just identify that these are two different equations here. Okay? Now, before we jump into subbing in or using the technique of substitution, we have to analyze this, right? So we know that in a system of linear equations, there are either one solution, zero solutions, or infinite solutions. And we know what that graphically looks like. Now, we see here that our system of linear equations here, they have the same slope, right? So that means that they're parallel to each other, right? And if you look further, they have the same intercept. They're basically the same linear equation, right? So because of that, we're able to not even calculate what the substitution would be, and we are able to just simply say that this system has infinite solutions. Okay. Now, if we were to sub it into here, you would get that you would have basically 0 equals 0. And when you have a 0 equals 0, that means that you have infinite solutions. Okay? So other than that, this solution is correct because the junior tutor said that there are infinitely many solutions. Good work. Okay, finally, let's talk about question number